Hello everyone. In the previous video, we have looked at the motivation behind the subject theory of computation, and we have also looked at how computation is different from algorithm. In this video, we will be looking at the examples of how hardware and software can be modeled using the theory of computation concepts. So I will be taking an example, very simple example of a finite state machine, and I will be discussing the working of the hardware like flip-flops and how that can be modeled using the finite state machine. So let's begin with it. So computation model using finite state machine. First of all, we have to understand what is a finite state machine. A finite state machine is a machine in which we have a fixed number of states and we have one initial state and there are possibly many final states. The initial state is the point from where the processing will begin. That is when the machine will start. It will enter the initial states. Then depending on the input, the states are going to change. And if we change the states and reach a final state during that process, that means that the machine has successfully processed our input. But if we fail to reach a final state, that means the machine has been unsuccessful in processing the input. So there is a set of states, there is an initial state, there is a single initial state always, and there is a set of final states. Apart from this, in a finite state machine, there is an input which is going to be used for moving from one state to another, and the machine may also generate an output. The output may be in the form of a state or in form of some output variable. So for a machine to work, we need input, output, and how the states are going to transition. So these three are the most important components when a finite state machine is being designed. So let us look at it. So as we can see here, I have prepared a model, the finite state machine model for a T flip-flop. And there are four things which I have put here. There is an input variable, there is an output variable, there are a set of states, and there are transitions from one state to another state. So you all must be remembering those days when you have studied the T flip-flop and the NAND gate flip-flop, which used to make you feel sleepy in your computer organization class. But then I'm not going to go into the working of the flip-flop, but we have the truth table to our rescue. So we all understand T flip-flop is the toggle flip-flop. Toggle flip-flop means whatever is the input, if the input is 1, whatever is the previous state, that will get toggled into its opposite. So when the input is 1 and the previous state is 0, it will become 1. And if the previous state is 1, it will become 0. And when the input is 0, the previous output is going to be maintained as it is. So this is how the T flip-flop works. Now what are the input variables? The input variable is the T variable, which can take the values of 0 and 1. The output variable is empty because it is not generating as such any outputs. Then there are states. There is a Q previous state which can take the values of 0 and 1, and there is a Q next state which will take the values of 0 and 1. So there are two states, Q previous and Q next. Q previous is before applying the input and Q next is after the input has been applied. So when Q previous is 0 and the T input is 0, then the Q next will be 0 because T input is 0, then the Q previous will not change, it will maintain the old value. Similarly, when Q previous is 0 and T input is 1, the Q next is going to be 1. Now as you can see here, I have not specified the algorithm or the design which is going to generate this kind of an output, but I have simply mentioned the input, the output, the states, and the transitions, that is on application of an input on a given state will generate what next state. So I have just mentioned the computation which will happen. I have not specified the algorithm, how this transition will happen, what is the logic behind this transition, or what is the working principle, that I am totally silent about. So finite state machines, they model your hardware or software in terms of inputs, outputs and transitions. This is the guiding principle behind understanding the finite state machines. And as we can see here, this is a two-state finite state machine where we have one state in which the first 0 represents the Q previous and the second 0, it represents the output state, that is the Q next. Similarly here, the first one represents the Q previous and the second one represents the Q next. So on the input of 0, if the previous state is also 0, the output will be 0. And if the Q previous is 0, but the input is 1, we will toggle and we will move to the output 1. And similarly on the input of 1 as the previous state and input t as 0, we will remain at 1. But if we are going to give the input 1, we are going to toggle into the 0. So this particular model, this machine over here, it is representing this finite state machine and it represents this toggle switch. So I hope this concept is clear to you. So with this, I am going to end this video. If you find my channel useful, please subscribe to it and I will be sharing more videos with you. Thank you very much.